Good morning, ladies and gentlemen, and welcome to the live demonstration area. We are very, very pleased at the JEC World to be showing you during the next 2 days the groundbreaking technology which is shaping the landscape of all of the technologies in the composite parts manufacturing processes across industries such as aerospace, marine, railway, defense, electronics, and renewable energy. This is the first time that you can witness such revolutionary technologies at the JEC World, and we wish to thank our partners, Thermwood, Aerovac Composites One, Magnum Venus Products, and Roctool for making this experience possible. Ladies and gentlemen, the demonstrations will be taking place in English. If you would like a live translation in French, don't hesitate to get a pair of headsets from the hostesses. Mesdames et messieurs, les démonstrations vont se passer en anglais. Si vous souhaitez une traduction simultanée en français, n'hésitez pas de chercher un casque auprès des hôtesses. And now let's dive into our first presentation this morning with Roctool. Roctool's presentation will highlight innovative molding processes such as heated platens, showcasing a mix of high performance and energy savings. To talk about Roctool's heating technology, we are pleased to welcome Mathieu, the CEO, and Edouard, the Composite Business Development Manager. You will be able to ask them your questions at the end of the presentation. Gentlemen, the demonstration floor is yours.
Thank you, Joanna, and good morning, everybody. Thanks for spending some time with us. My name is Matt, and Edouard will be my teammate for this presentation. Also over there, Hugo, our engineer that will be running the machine and demonstrating our technology for you today. So a few words about Roctool before we start. We're a heat and cool provider. So we provide heating systems, engineering for heated platen or heating molds, using induction heating in different formats. And we also provide cooling system, obviously, because if you heat up, you have to cool down. We all know that. We couldn't just be a heating company. We had to be a heat and cool company. Roctool's been 20-year-old, and it's been 10 years that we're very active in developing state-of-the-art induction techniques. As a reminder, we're also in injection molding globally. So combining compression molding and injection molding, we have about 600 systems installed globally running our technology every day. So maybe we're going to start by presenting the type of equipments we have over there. But before Edouard share with you what we have over there, a few words about why we're showing this year. We wanted to come up with a new heated platen. We've seen a lot of customers that sometimes they say, we like your technology, you have the induction heating directly in molds. But sometimes we just have a small batch of production, and sometimes we have a higher volume. We cannot just buy a steel molds every time. So this time we make a dynamic heating system where you can replace inserts, aluminum inserts, and then you can swap different kind of inserts based on your platen dimension. The second thing that we're going to show is that the induction heating, the way we use it is integrated in the platen, with also cooling, and Edouard will show you the systems, but this allows you to completely outperform oil heaters or electrical cartridges that don't have the flexibility of heating and cooling as you wish based on your temperature profile. You can be making thermoplastic or thermoset. To have the heating capability makes a big difference. And finally, the last one is those heated platen, they can go up to 400 Celsius and plus, which also is quite an advantage when you have those high heat resins to take care of. We know electrical cartridges and oil, they can get there, but it's quite a ride to do it. And then when you want to have a faster cycle time, it becomes quite tricky. Okay, so I will let Edouard show you the system before we fire the demonstration.
Thank you, Matt, for this introduction. So, hello, everybody. So behind you, you have our new standard for the production of composite thermoplastic parts and thermoset, which is our IDS technology for Roctool Induction Dynamic Saver. You are here a standard compression machine with the integration of our new 18 platen. So as explained Matt, we have integrated our 3 high-tech technology, our patent technology, based off our induction heating system inside this dynamic heating platen. And for this live demo, we have placed on the top of this platen some aluminum mold. For this live demo, for this example, we use phone holder parts, and Hugo have placed, lay up the 3D knitting preformed textile for this live demo. So we can start now the demo. During I explain all the equipment that we have close the equipment. So on this RIDS system, we have connected our induction generators behind the machine. So this is our classical DZ 100 kilowatt. So it means that we have separately 50 kilowatt per side. So we can manage the top and the bottom of the process independently. And with these induction generators, we have two cooling units. One is dedicated for the mold. It's a C6 equipment with the capability to deliver 100 liters per minute at 20 degrees. And the second is for the component for the generators.
Thank you, Edouard. I think that that summarizes it well. So on the screen, you can see the temperature. So here we're going to go about 250 C or 230 C, okay? 240 C, okay. So now let's talk about our partner for that demonstration. So Saint-Gobain is our partner. Saint-Gobain is a manufacturer, and they, for aerospace, they have the capability with this technology they have to 3D knit preform of fiber and plastics together, so that even for very complex shape, when you have a very narrow or very deep cross-section, if you do that just with a woven material, we know it could be tricky with wrinkles, with drapability in the tool. So here you see it's a preform that is the shape that we're going to be molding. So there's different advantages in terms of mechanical performance, obviously, because you get exactly the fiber in the right direction. The second is when you place it in the tool, you know you're going to have a net-shaped part with very limited scrap of material. When you use woven, when you use all kind of other materials, you need to trim, you need to cut, and then it becomes a more, let's say, material waste that could be a problem. So Saint-Gobain Aerospace is using that with our technology, so a little bit of the best of two worlds, right? About the best of preforming with heat and cool capability. So this is what we're demonstrating, small inserts for this demonstration. And throughout the show, we're showing different kind of reinforcements, because once you have the right temperature in your manufacturing facility, you can go from chopped carbon to woven to non-woven. You can go to commodity resin temperatures, to high heat resin temperatures, because you know you've got heating capability. You know you have flexibility of heating and cooling. And between cycles, and this is very important to understand, between cycles, the hot platen can remain fairly hot, because we're going to cool down just the insert, and we're going to cool down the platen as well, but to kind of a step temperature, to be ready for the next cycle. So the power that we described before is being used to heat up the platen, and in between, we're going to dwell so that we're ready for the second shot, and which we're going to do now. And the second shot, as we do the dwell on the platen, we're using 5 to 10 kilowatts on a 600 by 600 platen. Okay, so very little energy consumption during that time. If you look at other technologies out there, conventional heating, which could be oil again, and electrical cartridges, they don't have this capability to do that. And another point is on the weekend, sometime manufacturing places, they hesitate to turn off systems because they know Monday morning, if they have hot press and they have a big batch of production, they're going to leave everything on, and it's energy waste. So here with induction, you have this flexibility. Start your platen. Look, we're doing it with you here. Actually, I don't think it's that hot at the show right now. We have the ability to quickly get to temperatures. So what's happening there on the thermocouple?
So typically with this interface controller, we can manage all the programmation of the cycle. In this configuration, you can see the two generators that are connected on the top and on the bottom of the mold. So you see directly the information about the heating step And so now we reach 240 degrees in less than 3 minutes. And we stabilize the temperature during 1 minute. As soon as we reach this constant temperature, we start the cooling, which is running at this moment.
Yeah, so in terms of cooling capabilities, it's about 100 liters per minute. So you do need cooling capability, obviously, to do it. But you don't need any specific, let's say, beyond that. So right now we're using ambient cooling temperature water for that demonstration. In terms of the platen is a steel platen, okay, because for a magnetic purpose and for good conduction, we need steel. The inserts, they can be aluminum, they could be nickel, they could be also steel, okay, based on your part and your material. You could require a different kind of material. That's also something our engineering team, they can simulate. And this is an important point. Before doing a project, we have recently made a 2.5 meter by 1.5 meter platen that we just equipped. And we were able to simulate the complete platen and also what's going to happen on the insert in terms of power, cycle time, heating ramp, cooling ramp, before making the mold, before making the heat platen. So that 2D, 3D thermal analysis, that's Roctool's core skill. And our engineering team, they provide that service based on your part or your dimension requirement.
With this material, so which is PC resin and glass fibers supplied by Saint-Gobain, we demold at around 80 degrees the parts.
So we demold 80 degrees on the insert.
Exactly.
But what will be the platen temperature when we demold?
90 degrees.
About similar for the demonstration.
Yeah.
But if we wanted to be in a production mode, we could have the platen a little bit higher if we wanted to, and keep cranking parts and so on. Obviously here, we're not going to do that today, okay? This is demonstration. Nobody has asked us to do production, thank God. But at the end of the day, what we want to show is something that is versatile enough so that you understand that the flexibility of controlling heating and cooling for manufacturing composite, we think is absolutely critical. Sometimes we find it kind of odd that throughout the whole show, we've been here for so many years, we spend so much time on the material, which is important, and not as much time on the process itself. We expect a lot from manufacturers to come up with a recipe that will save the day in cycle time, energy consumption, and so on. So our job is to come up and support the manufacturers in finding solutions, especially as more materials are coming. And as sustainability is at the door, we're going to have all kinds of those new resins that maybe will have temperature profile that will be different, that will request maybe more heat, maybe a faster cooling. That's when that technology becomes even more alive in this category of materials.
Matt, that's the time we can demold and open the press. So you see the
for demolding, which is
on the bottom of the
always
mold.
Tricky. So just to show, we made this little application the times Hugo is demolding, which is like a sock, which is polycarbonate and fiberglass, becomes obviously a fully consolidated parts. And throughout the show, we also make 100% recycled carbon kind of base, and it's a holder. And then what we do is, I asked something for my desk because just for the show, we do this for a little holder because we wanted the demonstration to be functional, not just making a plaque. And thank you.
That's a part.
So here we will circulate the little demo part around. A few words also about...
We can start another...
Yes, let's start the second one as we show the flexibility in molding.
Exactly.
A few words about this knitting technology. Here for the demo, we only have fiberglass. Actually, we made parts and we combine carbon fiber and fiberglass on the same knitting. They have the ability to 3D knit different reinforcements based on the parts configuration. That's something that they can do with this knitting technology. And if you have any questions, Saint-Gobain, they're around by the demonstration.
That's a very innovative material that we would like to show and combine with our technology. You can innovate with the production capability and to be able to produce in short cycle time thermoplastic composite parts with the interest to have also recyclability and no waste and durability about performance for the final
exactly.
part.
Like this is a part manufactured by Saint-Gobain that has the ability to 3D knit a section and also include a transparent, almost like a window in a one-piece molding with the 3D knitting technology and integration. So all of that is molded, heating, cooling, remove. There's no drapability issue. There's no oven preheating. There's no transfer. There's no cutting. So it simplifies the access to more complex shapes, integration, and quick cycle time.
Exactly. Perhaps we can have a short description about the design of the integration of our induction system inside our IDS system or inside mold. So you see here, typically, in red, the integration of our inductors inside the mold. So it's a continuous circuit, which a copper cable, which is in case flexible or rigid. And you can follow the shape of the mold of the parts and to have a very homogeneous temperature and very good homogeneity for the transformation of your material.
Yeah. So induction is a safe technology. Induction is used in the industry for many things, for heat treatment, for brazing, for welding. In our kitchen, I mean, the induction technology is not something we came up with. What we do is we visit the induction technology applicable to molding. For compression molding, for injection molding, for blow molding. Now we have a lot of projects in blow molding for packaging. And it's always the same principle. How well can I heat my mold before my material is in contact with it? So that can be by injection, by blow molding, by compression, always the same story. Obviously for composite, there are longer cycle time because we have consolidation, we have different thicknesses, we have sometimes for thermoset, curing steps that we need to respect. So that's why we have those specific designs. The inductors are fully insulated within the tool. Okay, that's something. So there's no magnetic field circulating on the tool. This is within the channel, and then by conduction, we're heating to the surface. So we're just hot like any other medium that we could use, like oil or electrical cartridges or hot water, whatever it is. We're just replacing this medium by something way more effective.
One of the advantages of our IDS system is the versatility of the heat and platen. So for sure, you can use a lot of different molds. As I explained, can be in aluminum, in steel, or different alloy. And in this configuration, you can adapt the good dimension of your IDS system for your press platen. And you can use it very simple for any different case of an application. And you see that it's why also we showed during the live demo, you can use for a very large case of application from thermoset or thermoplastic composite material and from low temperature, medium temperature, and also for high temperature. So it's why also this solution can be improved for high temperature thermoplastic composite material as for our aerospace company, and to be able to heat at 450
exactly.
degrees.
Actually, this press is one of the old press we have in our lab. And we like the fact that we're not coming with like a brand new machine and so on. Not only that, I don't feel like buying a press right now at the moment, but the point is having existing equipment where you have an add-on platen on it, you reboost your existing capability and you can offer to your customer maybe more flexibility on cycle time, on energy consumption. A lot of the OEM circulating are asking about what is the energy consumed per piece. And I think this will become an argument in the future, more and more. Every time you make one piece, how much energy was being used? And I'm not talking about just the energy as you mold the part, but the whole process, what happens in between cycles. How much time is being dedicated to just molding one composite piece. And that's an important calculation.
So now you see that the cycle time, total cycle time is around 6 minutes. We have heating time is around 3 minutes, 1 minute for the holding time, and 2 or 3 minutes for the cooling. So you see that it's very short, and it's why also during this live demo we can show you some different repeatability for the production of composite parts.
Exactly, and if we look at it, think about cycle time from here is a 1 cavity for the show. What if you have 2 cavity, 4 cavity on your platen? Then you cut again your cycle time, you would be more in the range of 1 to 2 minutes per part. And here we're using a heated platen. We could also integrate the heating directly in the mold for maybe bigger projects. But the fact it's a heated platen means that the tool remains in place. And then if you have a new project, you remove your insert, make a new insert, place on your platen, and off you go. So engineering time is very small, very controlled.
We can explain, Matt, also that during the show we announced that we are new customers for this technology.
Correct, and I hope more.
In the sport and leisure market, which is...
In the sport and leisure. And I think one of the reasons, talking about this customer, is also the fact that we're showing, so throughout the show we're showing woven materials, demonstrations, non-woven, with recycled carbon, chopped carbon, unidirectional. Here we can see from Rungbo some materials which is UD tapes, and with a layer of woven. And we're also showing flax, natural fibers with polypropylene. The fact we have the quick heating, we protect the natural fiber, and we don't expose it too long in a heated environment, because that's something that could be an issue. And finally, this 3D textile demo that we're showing now. So through the show, we're showing 5 different types of composite structure throughout the demonstrations. Right?
We can open and demo the part now. So we open the press. And
so here's for the demolding. So as we have just 7 minutes left, I think we can take some questions the time we demold this one. If there are any questions, we'd be happy to answer. If there's no questions, I consider that the demonstration was perfect. That's typically, so if you want to ask questions, then I know what it means. But anything about the technology, performance, we're here for that. We have nothing to hide. That's why we're molding during the show.
Ladies and gentlemen, don't be shy. We have a microphone here if you would like to ask your questions.
Yep.
As you have 2 experts here, it is a perfect opportunity. Everything was crystal clear.
Perfect.
Well, this is
You have questions.
I do have a couple of questions for you.
That.
Can you tell me, Mathieu, what are the key advantages of this new technology?
Well, if I have to summarize, I would say number 1 will be flexibility in molding, okay, with this ability to make it more simple to manage heating when we make composite. Number 2, energy consumption, especially if you get in a bigger size. It becomes more dramatic if you're using conventional heating cartridges or oil. And I think as we go in the next few years, it's going to become more and more a challenge to keep up with the energy consumption. And number 3, the ability to go to high heat, to go 200, 300, 400 plus.
Okay, so this is another good question. Is it suitable then? Is the solution suitable for high temperature applications?
Yes, obviously when we do reach 300 plus, 350 plus, the design of the platen and how to make it compatible with the inserts would be a configuration that would be for high heat molding. Here, this platen and everything is more dedicated to 250 plus. Then we will need to look at the power and cycle time and so on. But yes, we also aim for PEEK, PEC, PPS, those high heat resin, PEI, obviously PEI being one of the key resins that we're looking at with this technology.
Okay, and one more question. Maybe you can explain why you chose this particular demonstration.
I think the point was to show how versatile we can be looking at very different formats of composites. Kind of a little bit to educate that you don't have to be stuck because you have one system in place that has limitations. So if you have limitations in place, it will always influence discussion with a customer not to jump on the process or not to offer something because you know what you have in the factory. And then you're like, oh, well, we can do that, or maybe so. If you know you have more capabilities, I think it can open up more discussions with the customers and bringing more performance in the manufacturing for multiple materials.
Okay, fantastic. So thank you so much, Mathieu and Edouard from Roctool. Ladies and gentlemen, if you do have further questions, don't hesitate to chat with them right now for a few minutes, or their stand is right next door. So this is a great opportunity to meet the Roctool team. And they will be back here at 12:15 and at 4:15 for their next demonstrations.
Thank you very much.
Thank you so much, gentlemen.
Thank you very much.